Hello, and welcome to my video for week 7, object-oriented principles. This is what I would say is probably the most important topic of the course. If you take nothing else away, you really need to know all about how object-oriented programming works, and in essence, that's captured by the principles that we're going to talk about in this lecture. Now, there are 4 object-oriented principles, and we're only going to really cover 3 of them this week. Next week, we'll go over the 4th, which is abstraction. But for now, we're going to start off with some exercises. So the notes are, of course, here for you to read, but let's look at some exercises that we can do. Make a program with a person class that has some private, public, and protected attributes or methods. And we'll experiment a bit with this to see what the difference is between each thing. Then we make a farmer class that inherits from person and a rancher class that inherits from farmer. Ranchers make more money than farmers when they work. So we clearly are going to need to have a work function. We can figure out some attributes that can be public, private, or protected. And we have inheritance. So this is, the concept that, you can think of what a person is. Well, a farmer is also a person, and a rancher is also a farmer, which means they are also a person. So we're going to be able to put in a few things from in here that are going to make sure that we can represent all 3 of these different concepts as accurately as possible. So first off, let's make ourselves a new folder, week 7, object-oriented principles. And in here, we'll start with our new file, CPP. We're going to do this all, of course, in regular CPP. I don't think it's appropriate to use a notebook for this part of the course, really. So let's grab our instructions. Zoom much, much closer in. There we go. Okay. There we go. Yeah. Okay. So we need a person class. Let's make a person class. Person. It's going to need to have public, private, and protected attributes or methods, and we'll see exactly the difference between these. But I guess we can make one of each. So let's say for private, we can have something like maybe their phone number. For protected, let's say their name, and then I guess maybe for protected as well, let's do actually for private as well, let's do their account. So their account balance, how much money they have, and then public, let's do, it's a good way to do this. Maybe I should just do phone number protected, name will be public. String name, there we go. So we have a private account balance, a protected phone number, and a public name. Why did I assign these this way? I mostly just want to show what the difference is and how these are going to work as we work on our code. We're going to run into some errors on purpose, just so you can see what the difference is between these 3 things, because we're going to need them. So we're also going to do a toString, because it's also nice to have a toString. And we probably should make that. So this is our person, our string, person, toString, and it's just going to return the name, which is their name, phone number, and a balance plus, I always forget how to convert string into string. I know how to do it the other way, that's STOI. No, always can just rely on c++.com to help us. I want int to string. To string, that makes sense. I can just do the variable dot to string, right? Oh, to string of the thing, that makes sense. To string of account balance. Now I want to make sure this works, so I'm going to write a quick main function which will build a person, And now we obviously immediately realize that account balance we're gonna have trouble accessing that. We might even have trouble accessing the phone number as well. So I'm gonna make some public set methods so that I can set those. So void set balance given an integer b is just gonna set our account balance to be b, and set our phone number given a string n. We'll set our phone number to be n. This is like a little bit monotonous, but this is the kind of thing that when you end up coding large classes, you end up having to do this sort of thing pretty often. And right now I want to make sure that I can keep these variables as protected and private for later. However, if I want to actually set them to something, right now I have no constructor. Maybe I'll make one in a little bit, but right now I just want to be able to assign values to these. I can assign the name of value, not a problem, because it's public, but these two are not public. So to make sure that I can, I'm going to use my set balance and phone. Now let's suppose I don't. I try to do p dot account balance is 100, p dot phone number is 1 2 3 4 5 6 7 8 9 0, and p dot name equals me, and then I try to do p dot to string. And we'll see what happens. I suspect it will crash if I am not mistaken. G++ my source, of course. So account balance is private, so I can't do that. And I need to declare strings as well. It's probably helpful. So I need to have include iostream, include string using namespace std, and also I should actually output the string so I can see it. Okay, let's try that again. So this time it's mad because no matching function call to person to string. So okay, is it the right to string? Yeah, it says it's to string. Maybe what I'll do is I should be careful about using the same name here. I'm going to use to string with a capital T here, and maybe that will help me out a little bit. Okay, so that got rid of that error. Now, account balance is private, phone number is protected. So this means that in my main function right now, I cannot access these things. I need to fix that, and I'm going to do so by using my get balance and set balance, or my set balance. So set balance is going to be 100, and set phone is going to be the phone number. And now this should work. All right, and this should be to string with a capital T. Okay, let's try this again. Compile, no problems. Run it. There we go. All right, all is well. So the idea of having private, protected, and public is what we call encapsulation. It's this idea that the class should not be revealing parts of it that others don't need to see. So you could even argue that maybe the name should actually be private or protected as well. And the reason for this could be that, for instance, maybe setting my account balance to just any parameter is actually bad. Maybe I should say something like, if account balance, if B is negative, don't do it, And so to set up protections to make sure people who are using your code don't do things that will cause the rest of it to break, you want to encapsulate, to restrict certain things, even though what the code is actually going to end up doing ideally shouldn't be affected too much. Now, here's a little person class. Not really that much fancy going on here. I just want to make sure it works. But this is important because we're going to inherit from this person class, so we need to make sure that there's nothing broken here. Now, I guess I don't need to go back to the slides. I got it up here. So I have a person class. It has public, private, and protected things. Now we're going to make a farmer class that inherits from person. So to do so, I'm going to make a class farmer that inherits from person. make sure that my syntax for this is right. I think so. Oh, I think it's just inherits from person without the word class. Is that right? Okay, cool. So this notation indicates that all farmers are people. And so if I do something like this, farmer f, and I do this with f.toString, let's actually just replace the person completely. We'll make this a farmer p. Whoop. Okay, we're gonna run into. I think this is where we're gonna start running into some stuff here. So, set balance is inaccessible within this context. Is that true? So farmer is a person. Interesting. Now this should be working, and I have to figure out why it's not. Because a farmer should be a person. Let's see. Did I declare my? Did I do my inheritance incorrectly? Let's find out. So let's see here. I think I have the format correct, right? Okay. I missed one thing, which is the access specifier. So when I'm inheriting from a class, I need to say what happens to all the parts of that class, should they be encapsulated in a certain way as well. So in the example from the website, it makes everything public, but maybe you want to make sure that everything from person actually is still private, for instance. We're going to make this public because I want it to work. And hopefully that should fix my error. Indeed. And look at that. Everything is the exact same, but I have a farmer instead of a person now. Which is interesting because what it means is that I can still make people who are not farmers if I really want to and do all the same stuff, but I can also make a farmer do other things. And we've seen in our description of what's going to happen here that there is something that they can do that normal people can't, which is work. So we're going to have a public method called work. And my work method belongs to the farmer class. I guess we'll work with a lowercase. And what it will do is it will increase my account balance by, let's say, 10. So, assuming that I did this correctly, which I hope I did, I should be able now to work. So you can do p.work. And then we'll see if it changes anything. I hope it did. Let's see. Oh, okay, what did I mess up? So this is where things get tricky for us. Account balance is private within this context. So over in my work method, you'll notice that the work method of farmer belongs to the farmer class. It does not belong to the person class. And in the person class, account balance is private. Now, what can I do about this? Well, first off, I don't seem to actually care about the phone number of the farmer. So I'm actually just going to make the phone number be private. And let's make the account balance be protected and see if that fixes anything. And suddenly everything is okay. Well, why is that? Let's look at the code for a second. The private phone number that we have is only accessed in a couple of places. One place is over here, where we have our set phone number. This belongs to the person class, so the person class is allowed to access the private phone number. Not a problem. In my toString method, this also belongs to the person class, so it can also access the phone number. Not a problem. Down here, I use the setPhone method to set the phone number. I don't directly access the phone number variable. And this setPhone method is public, so no problem. Now, account balance is protected. Let's see what happens if I write something like this. If I try to do, let's say, I think it should mess up here. Let's find out. P dot account balance is 20, just for fun. I was right. Account balance is protected within this context. And what that means is that in my main function, accessing account balance is not okay. Even though the account balance belongs to the farmer P, I'm not allowed to directly access account balance because I am in the main method. But there is one place I can access it other than inside the person class, which is actually inside the farmer class. So, doesn't work. In my farmer class, I'm inheriting from person. By inheriting from person, what that means is that I get access to all of the properties that are here. I can't modify this phone number unless I use the set phone method. I can't just go in here and be like, oh, this phone number, make it something else. Not allowed because the phone number is private. The account balance is protected, which means that over here I can't do this, but in my work method, I can. So the protected access keyword means that any of these classes that are going to inherit from person are allowed to modify the account balance because it is a protected variable, not a private one. If it was public, it would also be fine. And being public would just mean that I would be able to do this. But I'm leaving it as protected, so I can't. Now, I finally want to have a rancher, which is going to inherit from farmer. And I think this should work in that I don't think I actually need to put anything in here, because the only difference between a farmer and a rancher is the rancher is going to make more money. Now, I already have a farmer work method, but I want to have a different work method for the rancher. Now, I'm not sure if I have to declare it a second time. I might just be able to do this. I guess we'll find out. Work. And this is going to set my account balance to be 20. Higher. And we'll make this a rancher. And see if that works. I hope it does. Okay, no, so I do have to specify that I have a public work method. Not a problem. Just put it in there. And look at that. I have two work methods. One belongs to the farmer class, one belongs to the rancher class. If I am a rancher, I am a farmer, but because I am overriding the work method specifically for the rancher class, anytime that a rancher tries to work, which they do down here, it only will call the rancher work method. And in that case, it increases my balance by 20. Once again, the account balance is still protected, and I've said that anything that's from the farmer class is available to the rancher, so that works all fine and good. Okay, so I made a farmer class that inherits from person, a rancher class that inherits from farmer, and my rancher makes more money than the farmer when they work. Exercise 1 is done. Let's move on to the second one. Where are we? Over here. Separate them into separate files. Put both in a directory separate from your main code. Write a program that will create farmers and ranchers, have them work to increase their money, and include print statements. Not a problem. So, main.cpp. I guess so. I'll rename this as main.cpp. But you know, this code is getting long already, right? Like my main method is only a little bit. A lot of this is just person and rancher and stuff. But it's not a good idea to have all of your stuff in one file, and really most of your classes should have a file just for that one class. So here's what we're going to do. We're going to go and we're going to make some more files. And one is going to be called person.cpp. One is going to be called farmer.cpp. And one is going to be called rancher.cpp. Now, if I want to do this really properly, I should be making a header file for each of them as well. Just for the sake of keeping things a little short, I will probably try not doing that. If it ends up breaking, I might do it anyway. But Now what I'm going to do is I'm going to take everything in the main function that doesn't need to be there, so starting with the person and going all the way to main, cutting all this, that's going to go into my person class, which also needs to use namespace sd. I don't think I print anything, so it's okay to have nothing else, I'm pretty sure. If I'm wrong, I can always fix it. The farmer class inherits from person, and it's going to go in a separate file. So my farmer class is going to go over here. This one does not need namespace st because there's no strings in it. But what it does need is to include the person.cpp. I forget if I think I need quotes. I'll have to double check on that. And then the rancher is just part of the rancher class over here, which needs to include the farmer.cpp. And this is person with a lowercase p. And then finally, my main function needs to include person.cpp. Actually, it needs to include, I think, all of them, right? We need to include person, farmer, and rancher. Or I guess right now I only have a rancher, so I only really need to include the last one. I think I should be able to get away with this. Now, let's see if this works. Now, remember, because these are all CPP files, I need to compile all of them. So, I'm going to compile okay, what are all my files? So I need to compile main, farmer, person, and rancher, and output them into my executable. Okay, why are these all angry at me? Probably because farmer is missing the namespace. Oh yeah, I think all of them might have to have the namespace thing in them because they all use strings as part of their toString method. Let's see if that fixes some of this. Oh no, it's still kind of angry. Let's see. String does not name a type. String has not been declared in person. Oh, I think maybe this needs to have IOStream. That might be the case. Let's see if that fixes it. Oof, okay, what's going on here? Multiple definition of person to string. Now this might be because I'm trying to compile 3 files, each of which is trying to include the other ones. It could be the case that I might be able to just compile main. Let's see. Oh, look at that. So that's kind of handy. And if I run this, it should work okay? Yeah. Okay, that's kind of handy. Now, this is sort of what happens if you are not using header files, which is that, as you can see here, what I tried to do is compile every one of these 3 files. And what happens from doing so is that when I try to compile, let's say, rancher and farmer, they start to get confused with each other and say, well, you already declared person to string. Why are you declaring person to string a second time, given you already know that the farmer is using the person one, right? So when I compile, I just compile the main function, the main CPP, because it's including the rancher code over here, which is including the farmer code, which is including the person code. This won't always work for you. The main issues where this might be a problem is that, right now, it's really convenient and nice that, I have all ranchers are farmers, all farmers are people. But it might be the case that you have a different structure, and it might be a scenario where if you tried if you needed to have more than one include statement in some of these, things might go wrong for you. So this is the reason we would use header files. In this case, I don't need it because I have this really direct hierarchy. But in more complicated programs, you really want to have some of those header files, in which case you do need to compile each of the CPP files and your include statement should only include the headers instead, which should keep things simple. Now, okay, so what am I doing? I am, I should grab this, right? Okay, separate them as separate files. Also put them in a directory separate from your main CPP code. Okay, you can do that too. That's not a problem. Ideally, my person should probably be here as well, but that's okay. So what we're going to do is we're going to make a new folder. This is going to have farmers. It's going to include our farmer and our rancher files. I'm just going to put those in there. And then finally, our farmer includes person.cpp, but actually, person.cpp is not in this folder, right? If I try to do this again, clear everything, compile, we'll say, hey, where is, well, I guess the first issue is, rancher is not here. So I need to go get rancher, which is in farmers/rancher. But now I have the problem that my farmer class can't find the person file because the person file is not in the same directory. But where it is the directory one level up. So to go one level up, I need to do /person.cpp. All is well. No problem. Okay, so we've separated into files. Farmer and rancher are in a different folder. Write a program that will create farmers and ranchers, have them work to increase their money. Okay, let's make some farmers and ranchers. Not a problem. Now, let's double check. Can I make a farmer? I think I can, but let's make sure. Yeah, okay, not a problem. By including rancher over here, I have therefore included farmer, which means I have therefore included person. This is, again, only really working out for me because I happen to have this really direct line of things. Sometimes you don't get this lucky, and that's where the header files start to become more important. But in this case, I can just include the rancher, which means I have farmers. Now, right now, this was all just stuff to make sure stuff works. So this is my test code. Now, I need to create farmers and ranchers. So let's say I'm going to have 3 farmers and 4 ranchers just for fun. Oh, we'll say 2 ranchers. Okay, so now for I0, I less than farmers, I plus plus. We're going to make a new farmer. We're going to make sure that they exist. Actually, let's look at the instructions again. Create farmers and ranchers, have them work, and print it all out. Okay. So I want to do this dynamically because later on I'm going to change. I'm not necessarily going to have exactly 3, but I do need to have the actual lists themselves. So this, I guess, will be num of farmers, num of ranchers, num of farmers, and we're going to do farmer. Farmers equals new farmer 3. I believe I did this correctly. I'll run my code just to double check I didn't do something weird. And if I did this correctly, what I should now have is an array for 3 farmers to go inside. And now I can do farmer star f equals new farmer. Now I probably actually do need to have some constructors for this. Might be the case I can just do this. Let's see. I think this will crash, but we'll try it out. And I probably need to have... Oh, it seems like it's okay. Nothing happens. Let's copy some of this code. F arrow, because it's a pointer. Set balance 100. And F arrow to string. We're going to output that. Let's see what will happen. Compiles. If I run it, cool. I make 3 farmers. They'll have 3 balances. Let's make their balance instead equal to 100 plus I times 100. Now, I think we've done this correctly. So what we're going to do is we're going to have them all have different balance. We're going to get some names. Let's say Alice, Bob, Catherine, Dylan, Evelyn. 5 names. We can probably make more if we really wanted to, but 5 should be sufficient. And what we'll do is we will set f name equals names I. F set phone is going to be to, we'll just have everybody have the same phone number. It's not really a big deal. And now we should have 3 different farmers. Let's see if that works. All right, Alice, Bob, and Catherine, and each have a different balance. Let's have them. Okay, so let's do our ranchers now. So our rancher is going to look something similar. We're going to have ranchers. Oh, and this shouldn't be farmer 3. This should be new farmer number of farmers, and this should be rancher, ranchers, new rancher, number of ranchers. This is going to go up to the number of ranchers. We're going to set their balance similarly, but this time the names are going to be I plus the number of farmers. So that way we're grabbing the rest of them. We won't output anything. Or I guess we can put them out here. So here we go. We got our farmers. And then over here we have our ranchers. And I'm putting in a new line just to space it out nicely. Then we'll get our farmers, then we'll get our ranchers, and then we will I'm actually kind of curious if I can put all these people into a person array. I think I can. We'll try it. Let's see what happens. Person array. Persons equals new person. Number of farmers plus num of ranchers. Oh, I need to also put these into those arrays. So farmers I equals F. Ranchers I equals F. That way I have them. And then over here, okay, first let's make sure I've broken anything yet. Ideally, nothing should be broken. Okay, what did I mess up? I meant ranchers, yes, with a small r. Did I? Yes, ranchers here with a small r. What did I mess up now? No match for operator equals farmer and oh, right. So F is a pointer to a farmer. I want to put the actual farmer into the array. Let's try that again. Okay. So I got my farmers, I got my ranchers. Now I'm going to try to put them in the persons array. I think this will work. Let's find out. So for, basically for each farmer, put them in my person array. Let's get some more space on the screen. Actually, here's what we'll do. Rather than making more loops, let's make this thing over here. Let's make all of our lists all together, just to make this a little cleaner. So I got my list of farmers, a list of ranchers, and my list of persons, which in my person list is going to have everybody. So for each of my farmers, I'm going to put them into my farmers list, and I'm going to put them into my persons list. And then over here, I'm going to put them in my ranchers list, and I'm going to put them in my persons, I plus the number of farmers. Now, let's see if that works. I think it should. All is well. And now, so this is the magic of polymorphism. So ranchers and farmers are all people, right? Which means that my persons list is going to have a bunch of farmers in them and ranchers in them, all of which qualify as people, but they are different because some of them work better than others. Now, what I'm going to do is for I is 0, I is less than the number of farmers plus the number of ranchers. We're going to have everybody work. So we'll have persons I dot work, and then persons I dot to string. I'll output that. Let's give it a shot. That's right. Because a person can't work right now, so I have that issue. So what I actually should do is I need to change this list, because although both of them count as people, people right now can't work. So instead, what I'll do is I'm going to have a second farmer list of persons. Why are you mad? Invalid conversion from... Oh, right, sorry. So these persons are all farmers. But it includes both farmers and ranchers. So I'll just leave it as being called persons. Compile, run. Okay, so here's everybody. Everybody works. Oh, that's interesting. Okay, well, I mean, I guess that's just how this works. So you'll notice that Dylan and Evelyn are ranchers, right? If I go and I say, each of you ranchers go work. So, F work, just for fun. You'll see that their balance increased from, what was it before, 110 to 130, because ranchers work and they get double. But if you notice, when we made everybody a farmer, so let's run this again. When they worked, they only gained 10. And so the reason for this is that even though Dylan and Evelyn are both ranchers, when I go over here and I say persons I dot work, persons I is all farmers, which means that the work that's being done here is specifically the work that belongs to, is the work method that belongs to the farmer class. And the farmer work method means you only gain 10. If I wanted, for instance, for my ranchers to gain their 20, what I have to do is I have to go through each person and see what kind of person they are. Now, I think I can do, I think there is a check I can do for that. Is type. Yeah, I want to know, I forgot what it is. There's a C++ thing that lets me tell you what type. Type ID. I think that's it. Let's see if that works. So here's what we're gonna do. So everyone works as a farmer this way. I want people to work as a farmer and as a rancher. So if type ID of persons I is the type ID of a rancher. I think I have that correct. Then, I guess that's a tricky question too, is now how do I make sure I call the rancher method. I have a bit of a puzzle, don't I? We have to think on this one a little bit. Because if I just access them via the person's I work method, it will call the wrong one. I want to call the rancher one. So how do I do that? Maybe it's in one of these notes here. I know there's a way to do it. It's just trying to remember like what is the exact way. I think it's something like this. We're gonna explore a little bit with this and see if this works. We're just experimenting a little bit. Maybe that's not it. Tricky. So I don't really want to typecast. I want to use polymorphism. And I want to, I want to do inheritance effectively. I inherit the things, yes. And it's really missing here. I wonder if the other notes will have something. I know there's a way to do this, and it's bothering me that I can't remember how to do it in C++. I know how to do this in other languages, but okay, maybe these notes have something. Let's do a little research here. Is there no polymorphism under these notes? No, it's just under inheritance. That's not helpful. Classes in action? Does this include... No, this doesn't include inheritance, I don't think. I think I have to cast it. I think what I'm supposed to do here is I'm supposed to specify that the maybe I can do it like this. So if they're a rancher, first let's make sure this is actually valid code. I don't even know if this will compile. Okay, it says it's okay. Let's make sure that this is identifying ranchers. I should see that this is printed twice because I have two ranchers. So if I match two people to ranchers, then it should say rancher found for each one. And there are two. So let's see. Okay, it found none. So that's not good. Oh, because right now I think it's just treating them as... I wonder if maybe it's converting them. Maybe it's actually the case that what this is doing is it's transforming these ranchers into farmers. It could be. Oops, did not mean to do that. Well, you know what? We're just going to go the lazy way, I guess, which is, it says to have everybody work. What we can do is, so we know everybody has a toString. What we'll do is we'll make them work separately, and we'll do the toString together. So here's what we'll do. Is we're going to have everybody work. And to have everybody work, we need to go through each rancher. And have them work. Oops, sorry. It should be ranchers I.work. And the same thing for the farmers. Right, and now I need to, so once they're done working, then I want to put them in the persons list. Okay, now this should do what I want. What did I mess up? Oh, it shouldn't be F, it should be farmers I. Ranchers I. Okay, there we go. I think that'll wrap up our first two exercises. I'll maybe yeah, I can handle the third one. I think in a little bit. I do have to take a little break because we've been at this for a bit. But what happened? So we got our farmers and our ranchers. Everybody works, and you'll see all of the farmers increased their accounts by 10. All of the ranchers increased it by 20. And that's because I told each farmer to work, each rancher to work. And then I put all of them in my persons array. My persons array, if I told everybody to work, they would all work as a farmer because they are all farmers. And in fact, I actually could go back here and make this person again, and this shouldn't break anything. I believe this should be totally fine. Yep, no problem. Does the same thing. Because the only method from person I'm calling is to string. And so if you want to make everybody work, I have to change the person array to a farmer array if you want everybody to work. But if you do this, everybody works as a farmer, not as whatever their specific type is. So to make sure that I'm making the ranchers be ranchers and the farmers be farmers, they have to do their specific job. Once they've done their job, I can put everybody into a list that all treats them all equally as all persons, and all persons can be printed out the exact same way. So there we go. I'm going to pause the video for a bit and come back to it, which is basically just going to be me making a make file, which is going to build this and also pass some parameters, because right now I, using 3 and 2, we want to be able to ask how many farmers and ranchers they want and do the same thing. Most of the code is here for this. I'm just going to need a few more names maybe, and I will we'll get back to that shortly. But this is the first part, and I'll come back for the second. Okay, let's wrap this up by making a make file, and I think we'll also go ahead and we will make some headers and everything. So we're going to clean all of this up, make it as nice as possible so that you can use this as a reference. Okay, make a make file that will run your program, modify the main function to accept command line arguments that will determine the number of farmers and ranchers that will work. Okay, let's take this for our reference. Okay, now, right now we're including CPPs. It's not a good practice to do this. Let's put our instructions in here because we're going to need to remember them. Zoom in a little bit because this font is real small. Okay. Now, I'm going to need to make file, but before I do make file, let's make some headers for things so it's all done a little more properly. To do this, what I'm going to do is I'm going to start off by going over, oh, I made a notebook, I don't want. Going over to my rancher here, and we're going to make a header file for this. And it's going to be really small and really simple. Probably not necessary to do this, but I think it's good practice anyway. So here's my rancher header file, and my rancher header file is going to include farmer.h when that is done. I don't think I need namespace std. And I don't need to say what the work function does. I just need to say there's a rancher class, it inherits from farmer, and it has a work function. Done. That's it. So real simple. Took me 2 seconds, you know. Now, I also need a farmer.h. Also going to be very simple. So farmer.h. We'll close our rancher.h because we don't need it. And we don't need to include farmer.h. We're going to include, or farmer.cp, we're going to include farmer.h. Okay, so that can go. Farmer.cpp looks like this. So we're going to make our farmer.h also simple. We don't need the work function. We just need to say that it exists. and we're going to include person.h, which we have to make as well. And this is going to include person.h. Again, I don't think I need this namespace std. That can go away. And now let's make person.h back in our directory over here. Person.h. Our person.h is going to be like this, except it is not going to have this code, and it's not, I think I'm going to leave these here. I think that's fine to leave as is. And again, I do need these because I do have a string in here, the phone number. So I believe that has to stay. Okay, and my person.cpp doesn't need to include anything. It is fine. My main function here can now include, I think I can include all of the .h's and it should be okay. We'll see what happens if I do that. So I need farmers/farmer.h, rancher.h, and person.h. And we'll see if that is necessary. I might not need to include all of these, but I'll do it anyway just in case. You never know. So, okay, I got all the header files. They're all in the right places. Let's make sure I can compile this, and then I can make the changes for the command line arguments. So, for compiling, I need to compile main person.cpp, farmers/farmer.cpp, and farmers/rancher.cpp, and put them all into my executable. Okay, what did I mess up? Right, redefinition of things because I am importing more stuff than I need to. I think, again, I can probably get rid of these and that should deal with that. Let me see. Okay, so I only needed to include the rancher header file. Now, if I output, it should still work totally fine. Everything is exactly as I remember. That's great. Now, I need okay, so I got my header files now. Now, this thing I wrote out here is really long and annoying. So that's why we're going to have a make file for this. And I guess we can do the make file first. That's probably fine. So, make file. Okay, so make file. Our target is going to be all, and we're going to need main.cpp, person.cpp, farmers/farmer.cpp, and farmers/rancher.cpp. G++, these things, and output into an executable. And if I want to run it, then I can do. Oh right, this doesn't like the proper tabs. I remember doing this last time and it complained at me for using the weird tabs. So let me go and grab my make file from last time so that I have those. Yeah, I need this. So I want this arrow to go there, and I want this arrow to go here, and /exec. Is there any other thing I need to grab from here? No, I don't think so. Okay, so that should be fine. Let's go back and make. Okay, make run. Great. We can probably add more to this, but I might just leave it here and keep it simple. The focus is not on the make file right now, it's just on the classes. But what I do want to do is modify it so it will take some parameters. So right now we're always making 3 farmers and 2 ranchers. I want more. So in my main function, I'm going to have an integer argc, which is how many I got, and an integer or a character pointer argv, yeah, which is going to have the actual things themselves. So the number of farmers, so I guess here's what we'll do is, if argc is equal to 2, then we will do one thing. Otherwise, we'll do what we were used to doing. Actually, not 2. It should be 3. Because one of the arguments is the file name. So argc being 3 means I should have the file name, a number for farmers, and a number for ranchers. Otherwise, I will do this. So right now, nothing should change if I run this again. Oh, I need to initialize the number of farmers variable first. We'll do it like this then. So initialize the variables, and then if the arguments change, then I'll switch. Then I'll make number of farmers will be now here's a question. Can I convert this using stoi argv1? I'm not sure if this works, so we're gonna try it. Make run. Okay. Now in my make file, the one that we're using right now, I'm gonna have another, we'll call this one params, and this will be executed with, let's say, 2 farmers and 1 rancher, and we'll see what happens then. Make params. And there we go. Now I only have 1 farmer and 2 ranchers instead of 3 and 2. And if I wanted to have more, I can. Right now, the reason that might not work is because I only have 5 names. But if I make a giant list of names, I can make these numbers a little bit bigger. So let's just review everything that we've done, and then we'll call it for a video, I suppose. So going over what we've worked on here, we have made 3 classes in separate directories even. One being person, which has a private phone number. Only the person class can access this phone number, nothing else. We have an account balance, which is protected. So the classes that are also persons can access the account balance, but my main function cannot. And we have some public stuff that actually can be accessed by anybody. So the name of the person, converting them to a string, setting their balance, or setting their phone number. Now, the farmer class is a person, so it inherits from the person class, so we have to include that. And it has everything a person has, plus they can work. And when they work, their account balance goes up. The rancher, which I guess I closed the file, so I'll reopen it, is just like a farmer, but if they work, their account balance goes up by 20. So they make more money than the farmer, I suppose. Now, in my main function, I wanted to test all of this out, see what happens. I have 2 ways that I can set up the number of farmers or ranchers. I can either have them 3 and 2 respectively, or I can get them as arguments from the user. And so I can say, hey, I actually want 1 farmer and 4 ranchers or something like that. Oh, I put the wrong number in here. This should be number of ranchers, not number of farmers. I hope that doesn't break it. Make all. Make params. Yeah, okay, so there's 2 farmers, 1 rancher. I had it the other way around, I think, by accident. Not a problem. Now, I get the number of farmers, converting the text of the number I typed in into an actual integer, and do the same thing for the ranchers. And then I set up 3 dynamic arrays that contain enough space for the farmers, the ranchers, and then one that fits all people. And those people are the farmers plus the ranchers. Now, I output all the farmers so we can see them. I set their balance to be a bunch of different numbers, 100, 200, so on. And I grab their names from the list. The phone number is all the same. I put them out to a string. And once I've created these farmers, which I've been doing dynamically, I put all of them into my farmers array. This is dynamic array. And the farmer I made in here was created dynamically using a pointer, so I have to dereference the pointer to put it in the array. I do the exact same thing for ranchers. Then everybody works. Now, we noticed earlier, if we put everybody into our persons array and have them work, They will all work as a farmer, assuming my person array is a farmer array. If I do them separately, however, I tell each farmer to work and I tell each rancher to work, they work using their respective version of that function. Even though each rancher has access to this farmer work method, they will call their specific one if it's known that they are a rancher. Once everybody's worked, they go into the person's array. So I put all the farmers in first and all the ranchers in second. And at the end of the day, I can just output all people because they all have a method called toString, and it will do the same thing for everybody. There's some test code here that I used earlier on to show how count balance wasn't able to be modified out in the main function because it's protected. And obviously the phone number can't be changed either. And all this code is available on Jupyter if you want to check it out. So thanks for watching. Hopefully this is a useful guide to a few examples we're doing in polymorphism, but it's definitely worth practicing these on your own as well. Just watching the videos is never enough, so always get more practice. There's plenty of questions out there you can try out. So thanks for watching, and I'll see you in the next video or in class. See you then.